Hello, you absolute legends. There are 4 primary intermolecular forces we discussed in Gen Chem, and we use intermolecular forces to predict physical properties like melting point and boiling point. These forces occur between molecules. In previous videos, I've discussed the ionic bond and hydrogen bond, when it's possible, when it could happen between molecules in solid, liquid, or gas phase. Now, if a molecule cannot form an ionic bond or a hydrogen bond, then we consider if a dipole-dipole interaction can occur. Now, the criteria for a dipole-dipole interaction to occur is that there has to be a lone pair of electrons present, and that's it. Only a lone pair of electrons present. This is a ball and stick model of acetone or 2-propanone or dimethyl ketone, DMK. You can find bottles in nail salons called acetone-free nail polish remover that don't have acetone in them. And also if you go to the paint sections of hardware stores, you can buy bottles of acetone or dimethyl ketone. Note that this molecule would fail an ionic bond test. It has a negative end, but it doesn't have a positive end, so it fails. Hydrogen bond, it would fail the hydrogen bond test. It does not have a hydrogen that is bound to an oxygen, nitrogen, or fluorine. Dipole-dipole, it has a lone pair, so it would form dipole-dipole interactions. Now, in a sense, a dipole-dipole interaction is a positive-negative attraction to one another. These negative electrons, or excuse me, negative lone pairs are made of electrons. They're going to be negatively charged. And there's nothing over here to counter or stabilize that charge. So we can effectively say that this molecule has a positive end. You can see a little positive sign on the end of that arrow, and a negative end over here, almost like a bar magnet is how we're describing it. So if another acetone molecule were to show up in liquid phase, it would be unlikely for these molecules to align like this, because the negative ends would be close to one another. And that's no good, that's repulsive. They would probably form an interaction, a geometric orientation like this, where the negative end is attracted to the non-negative end of each other like this. So their arrows are aligned like this, horizontally, or if we were trying to align them vertically, this would not be a good orientation, because again, the negatives attracted to one another. It would probably orientate more likely like this in liquid or gas phase, where again, the negative ends are far apart from one another as possible, and these positive negative ends, partially positive, partially negative ends, are touching each other or getting closer to one another. I hope this helps. Thank you.